Welcome to this module, where we will discuss deploying large language models into production. Deploying into production simply means taking a local development to a production environment where users can access and utilize the model to receive data-driven responses. Once we move applications to a production environment, they become available for various web applications, enterprise software, or even the end user via APIs to consume them. In this way, they reap the benefits provided by this model. Therefore, deploying a large language model into production is tantamount to moving it from a local to a productive environment. Let's use an example. Imagine a large language model that utilizes a database. The first thing we do is acquire the raw data to use in the production model. We develop the pipeline that contains the call to a vectorial database. Subsequently, we program the large language model through a framework, be it Python, LangChain, or Flowise. Once we have the entire project functioning locally, we generate an endpoint that can be accessed to utilize the model. Thus, we distinguish two phases. The first would be the local development of the project, and the second involves transferring this local project to a productive environment. This way, a user can directly consume it from an endpoint without the need to install anything locally or develop additional code. This move to production can be approached from different perspectives and using various methods. It is important to remember that a business user isn't going to know how to install libraries or develop code to access the model. Therefore, we need to develop an interface, either in the form of an API or an application to facilitate the consumption of the model. In this regard, we have two main avenues. Through an API, whereby the user would obtain answers by making calls to it, or through an application. Ideally, this would be an easy-to-use, intuitive application to utilize the model. In both cases, the user wouldn't have to deal with installing libraries or handling complex codes. If we choose an application, for instance, we could integrate the Flowise project into our website. This way, users could access the model through a chat and interact with it. If we opt for an API, we would need to develop it to call upon the model, using modules from either LangChain or Flowise. In this task, we will address what an API is and how we can develop APIs using Flowise. Let's start by defining what is an API. The API, short for Application Programming Interface, acts as an intermediary between two independent applications that wish to communicate. If we want all the developers to use and integrate our application, it is crucial to develop an API that serves as an access point. In this way, developers will interact with this API via HTTP requests, allowing them to consume and work with the service we provide. You can think of an API as an abstraction of the application. Users won't see our code or need to install anything specific. Instead, they will make calls to the API using HTTP requests. This abstraction facilitates integration with third parties, simplifying the connection with other solutions or APIs. Before using an API, it is vital to know the available methods and the response codes it might return. Regarding HTTP methods, it is essential to know what actions an API allows and to choose the appropriate method for its task. We have 5 main HTTP methods. Get, to retrieve an existing resource, read only. Post, to create a new resource. Put, to update an existing resource. Patch, to partially update an existing resource. And delete, to delete a resource. When using these methods, the API will return a response accompanied by a HTTP status code. These codes can start with indicating that the operation was successful, representing a redirection, pointing to a client error, and indicating a server error. With a basic understanding of APIs, let's turn to the Flowise documentation. Here, it highlights two main ways to use Flowise models: through APIs or by directly integrating them into a website or frontend. If we choose the API route, the deployment section provides several programming languages we can use to interact with the API automatically generated by Flowise, including Python, JavaScript, or directly calling the URL. Additionally, we have the flexibility to adjust the API's configuration by modifying input parameters, labels, and responses. Next, we'll make a call to a Flowise project using Postman, a tool that makes testing APIs easier. Using Postman, we'll see different parameters, some mandatory like question and others optional, such as a configuration or history. The documentation also provides details on how to set up an API for specific projects, like those involving uploading a document. With Flowise, we have the option for the model to learn from various documents or information either in PDF or TXT format. If a project requires this information, it will be necessary to pass it to the API so it can send it to the model in production. The first thing we did was access Flowise. We also installed Postman, which has an easy installation process. To do this, just go to postman.log and from the Applications page menu, select the appropriate installer for our system. In this case, we choose Windows 64. Upon selecting this option, an executable file downloads. Following the installation steps and registering for free with an email, we accessed the Postman environment, ready to make calls to the API. The next step is to develop the API. We'll base it on a straightforward project with a few components. As an example, I'll mention one that consists of a conversation chain with memory for the model and a call to the ChatGPT model. How do we generate APIs in Flowise? Once the project is saved and tested, we need to head to the top of the interface. There we'll find several options. We can embed the project on a website, either as a pop-up or in a full-page HTML format. Calls to the models in different programming languages like Python or JavaScript or directly through a URL are also offered. A recent and innovative feature allows us to share the chatbot with others. Focusing on calls from Python, we see that an API URL is required to get predictions. This requires a mandatory parameter, question. By copying this URL and going to Postman, we change the method from get to post. Add the URL and the required parameter. This step is carried out from the body section in JSON format. If the project needed a TXT file instead of memory, this JSON format would change to TXT. After adding the question variable, we can interact with the model, either by making a query or having an interactive conversation with it. It is worth noting that with a free account, there are limits to the number of calls to the model. If we use calls to the tab GPT model, we need to ensure we don't exceed these limits. As we have observed, making calls using Postman to our model is straightforward. Alternatively, we could make the call directly from Python. We would only need to input the complete code into a Python environment to get responses. In this way, we could move a local project to a production environment, like a server that will stay active supporting users. They wouldn't need to install anything, as they would only require making the call to the provided API, be it through Postman, Python, or any other option that Flowise allows. In this task, we'll explain how to introduce an authorization process using credentials when consuming our models. Typically, our models will not be public. Instead, we want them to require a series of authorizations or verification steps for users to access the models. But how is this done in Flowise? In the production deployment section, corresponding to this button here, we can see that in the different languages we have the option of no authorization and the authorization option. In Flowise, if we don't want our models to require authorization, we would simply leave the default state as no authorization. Otherwise, we would have the default key, or we could add our own credential. And how do we add these credentials? It is simple. We need to go to the API keys, select credential, assign it a name, and click add. Once this is done, the credential will be created and registered. From this section, we can also copy it. With the credential already in the API keys, we can return to our project and select the credential we just generated. By doing this, we'll see how the code changes. For instance, an authorization header and an additional variable called application.json are added. To test these credentials, we copy the URL to enter them in Postman. This URL should be entered within the post method. Subsequently, in headers, we need to copy the content type section and its corresponding value. In the authorization section is where we switch from no authorization to authorization via a token. This is precisely where we need to pass the previously generated token. To do this, we go back to the API keys and copy it. After adding the token, in the body, we just have to add the instruction, as we did previously. We know there is a mandatory parameter called question, where we will introduce the interaction with the model. To verify that the authorization process works, we click on Send. If everything has been set up correctly, we will get a response. As an additional test, we can enter an incorrect token to confirm that the authorization system is active. When doing so and clicking Send, we should see a message indicating that we are not authorized. With these steps, we can easily implement an authorization process to consume our large language models. In this task, we will explain how the system works for uploading PDF files to call the large language models through APIs. As we already saw in the Flowise documentation, to connect with a project that integrates a data load, whether it is through PDF, TXT or any other type of file, it is necessary to send the file via the API so that the model and the project can function. How would this be configured? Here it tells us how to do it from the document loader section. It points out that the project without data loading, everything is done through JSON. However, when we need to load data, we should go to the additional options and in the parameters section, under Files, indicate the type of file we are going to upload. In the case we are viewing on screen, the information is loaded from a TXT. Therefore, in the Files section, we will call that TXT, we will need to modify the file name, and what this achieves is accessing the TXT and loading it with the open function. The information is then sent to the API. If we needed to load the information from a TXT, for instance in this case called a state of union, we would have to send the call to the API. In the file section, indicate the correct name of the file, and in body data, pass the query. This is an example of what a code would look like that calls the Flowise API, in which we need to load a TXT. It is crucial that we modify the type and format of the file according to what our project requires. If we need a PDF, it should be a PDF and not a TXT. If we don't adapt it, we will face loading errors and it won't work. Next, we will see an example of a project that requires a PDF file to generate a series of indices within Pinecone's vector store. It then uses a large language model, specifically GPT 3.5, to query the information from that document. If we wanted to put this project into production and consume it through an API, we should go to the API endpoint section. Depending on the programming language we use, we will select one of the available options. It is essential to activate the Show Input option to be able to modify the settings. We can see that the first option would be a PDF file. In example, we should replace the name with that of our PDF file. Then we would need to remove some options like Open API Key and Model Name since we provided them with the project earlier. Finally, we find the section where we will introduce the query related to the information from the PDF that we want to make to the model. In summary, this is the way in which we can consume, through API, our large language model that requires information from a PDF. In this way, we could make queries about information contained in that PDF through the call to these APIs.